So what if I told you that there's this invisible thread connecting the pencil on your desk, the work of national security, and even the cash in your wallet? Well, today we're going to pull on that thread and see just how deep the connection goes. We're talking about a single element that links the totally mundane to the absolutely miraculous.
Let's just start with a little puzzle, shall we? What one thing ties together the simple graphite and a pencil, the really sophisticated tech used to detect bombs, and the tiny chemical traces on a dollar bill? It sounds like a brain teaser, I know, but the answer is actually hiding in plain sight.
And there you have it. It's carbon. It's an element that's so fundamental to, well, everything that we kind of take it for granted. But listen, we're not talking about your everyday run-of-the-mill carbon today. Nope, we're diving into how scientists are twisting, layering, and basically re-engineering this basic building block into materials that have almost magical properties.
Okay, first up, a material remade. We're going to look at how scientists are taking something incredibly simple and transforming it into something, well, something super.
So, think about the graphite in your pencil for a second. It's soft, right? It's brittle. It breaks pretty easily. Now imagine you could peel that graphite down to a single one-atom thick layer. That is graphene. It's still just carbon, but now it's transparent, it's flexible, and get this, it's over 200 times stronger than steel. It is a total game changer.
So the big question is, how do you even make this wonder material? Well, scientists are getting seriously creative. The research points to methods like, and I mean this literally, blasting surfaces with graphite powder to make it stick, or tweaking components with silicon carbide. But there's an even more surprising method that's both sustainable and, frankly, genius.
It turns out one of the most exciting new methods actually uses lignin, which is basically just wood waste from the papermaking industry. By hitting it with a really rapid, high-temperature process, scientists can create high-quality graphene. We are literally turning trash into one of the most valuable materials on the planet. How cool is that?
Okay, so we can make these incredible materials. Awesome. But what can we actually do with them? Well, that brings us to their applications. And it's a world of both immense power and incredible precision.
First, let's get a key term down: energetic materials. It's just the scientific name for stuff that stores a huge amount of chemical energy. So think of anything from the fireworks you see on the 4th of July to rocket propellants to high explosives. They're all about releasing a ton of energy, really, really fast. Now, to study explosions, scientists need to be able to measure their force, and a key metric for that is something called the maximum rate of pressure rise. Look, forget the formula. All you need to know is that it basically means how fast does it go boom. It's a single number that nails down an explosion's power and speed, and understanding this number is absolutely crucial whether you're trying to create a controlled blast or detect an uncontrolled one.
And this really brings us to the two sides of the same coin. On the one hand, you have scientists working to create and control this power for things like industrial blasting or even amazing fireworks shows. But on the other hand, a huge amount of research is focused on detection, building advanced sensors to find these materials and help keep people safe.
Which, of course, leads to a massive challenge for security and defense all over the world. How do you reliably, cheaply, and effectively detect a substance like TNT? And this, right here, is where our carbon story comes full circle.
This is where the science gets so incredibly accessible and just cool. Researchers created a special conductive filament by mixing recycled plastic with, you guessed it, graphite and a bit of castor oil. Then they just used a standard 3D printer to print a sensor. And when that sensor gets near TNT, it creates a unique electrical signal that's easy to detect. It's this brilliant mix of recycling, 3D printing, and some really advanced chemistry. So, we've seen the materials, and we've seen their applications. But how do scientists actually see and understand what's happening on a microscopic level? Well, that requires a pretty special toolkit for seeing the unseen.
Let's start with another surprising example. We all handle money every single day, but have you ever stopped to think about the hidden chemical story a single banknote can tell? For forensic scientists, that dollar bill is like a diary.
So, using a technique called ion chromatography, which is basically a super fancy way to identify tiny chemical traces, scientists can read a banknote's history. Fresh, uncirculated, clean notes have a standard chemical profile. But notes that have been seized in investigations, they often show higher levels of specific ions, which makes them cluster separately when you analyze the data. This chemical fingerprint can actually tell a story about where that money has been.
But what about seeing things that are impossible to film, like an explosion at the molecular level? For that, scientists use something called molecular dynamic simulations.
And this quote just captures it perfectly. They use these massive supercomputers to simulate the entire process, atom by atom, giving them a slow-motion replay of an event that, in real life, lasts for just a few microseconds.
And honestly, that's just scratching the surface. The modern scientist's toolkit is huge. They use X-ray diffraction to map out the exact atomic structure of a crystal, machine vision to automatically check microscopic surfaces for flaws, and even something called microtomography. Think of it like a tiny CT scan for rocks to study exactly how they fracture under a blast. Each tool gives them a unique window into this completely unseen world.
So what's the big takeaway from all this? I mean, from turning wood waste into graphene, to 3D printing sensors that can detect explosives, to reading the secret history of a dollar bill, the pattern is pretty clear, right? The key to solving some of our biggest challenges really does lie in understanding and manipulating the world at its smallest, most fundamental level.
And that leaves us with one final and kind of tantalizing question to think about. We've moved beyond just finding materials, we are now designing them, literally atom by atom. So if the leap from simple pencil lead to super strong graphene is possible today, just imagine what we're going to build tomorrow. Thanks for tuning in.